plus 1 raised to the 2/3 power. We want to find the first and the second derivative. So we'd like to find, I can either say find y prime and y double prime. The other way to write down my notation is I could write this as dy over dx and d2y over dx squared. So different notations, both mean exactly the same thing. Okay, so Erin, you were looking at this problem. What are your thoughts?
I did the chain rule on this one.
Okay, so our chain rule, we've got for y prime, our inside function is x cubed plus 1. My outside function is x to the 2/3 power. So my derivative of the outside, keeping the inside the same, derivative of the outside, I'm going to bring that 2/3 down. So I've got 2/3. Keeping the inside the same is x cubed plus 1. That will now be raised to the negative 1/3. Okay, because I'm subtracting 1 from 2/3. So that was derivative of the outside, keeping the inside the same, times derivative of the inside. So times 3x squared. Derivative of plus 1 is 0. Okay, so this is our y prime, and this is a legitimate answer for our first derivative. Any questions about that part? Okay, so now we're going to go on to the second derivative, and this is where you're running into some issues. Okay, so our second derivative, just like with this last example over here, it's going to be a good idea to do a little bit of simplifying first. So we can multiply the 2/3 and the 3x squared together. I can't do anything with this x cubed plus 1 because that's all raised to the negative 1/3 power. So my simplified version of y prime is going to be 2x squared times x cubed plus 1 raised to the negative 1/3. Okay, so now I'm looking at this y prime, and I'd like to take a second derivative. And when I look at these terms here, I see a power, but that power does not apply to everything. Okay. So the main property that I see is I see two separate functions here that are multiplied together. I've got 2x squared, and then I have x cubed plus 1 raised to the negative 1/3 that is my second function. And those two functions are multiplied together, so I'm going to have to use the product rule. Okay. So product rule says first times derivative of the second plus second times derivative of the first. Up here? So let's see. So when I multiply these together, my 3's are actually canceling. And I left me with the 2 on the top. Yeah. Okay. So first, 2x squared times derivative of the second, derivative of x cubed plus 1 raised to the negative 1/3. So first times derivative of the second plus second, x cubed plus 1 to the negative 1/3, times the derivative of the first, derivative of 2x squared. And so what I have written out up here is my product rule, but I haven't actually done the calculus yet, so I'm not done. Are there any questions so far?
So you can't just take the 2 and leave that on the outside?
Oh, that's a good question. So an alternative to this would have been to say that instead of the first being 2x squared, I could have had my first be the x squared, and just completely left the 2 out in front and said 2 times the whole product shebang, which would give you an equivalent answer.
Okay, all right.
Yeah. Okay, other questions? Okay. All right, so now I'm working through this 2x squared just gets carried along, and now I'm going to take the derivative of x cubed plus 1 to the negative 1/3, and this right here, that's a chain rule. Okay. Our inside function is x cubed plus 1 And the outside function is x to the negative 1/3. So our derivative of the outside, keeping the inside the same, will look like negative 1/3. Keep the inside the same, raised to, I'm going to subtract 1, so I'm going to have negative 4/3. Derivative of the outside, keeping the inside the same, times the derivative of that inside function, so my derivative inside is 3x squared. So we've got our first times the derivative of the second plus second, which is x cubed plus 1 raised to the negative 1/3 times the derivative of the first, and that's a nice easy derivative. Bring that 2 down and we have 4x times the derivative of the first. All right, so this is our y double prime. And I could simplify it, but I do not have to. All right. Well,
I have a question. Would you be able to post the unsimplified answers like on the webpage or something?
So yeah, so it's a little bit frustrating when you go to look at your answers in the back of the book and see if they are the same or not.
Yeah.
I can do some of them. If you have specific ones you want me to do, send me an email with those numbers in it.
Okay.
Because doing all of them, I probably don't have time to do all of them right now.
Oh, you don't already know the answer?
Well, I don't have it memorized.
I figured you would look at it and be like, hey, that's it.
No. I work them out just like you do. The problem is I usually end up working them out on the board so they get erased.